All right. Good morning, everyone. Welcome to session 3 of our Git and GitHub crash course workshops. I do apologize for running late. I was up far too late last night and still am currently a disaster, so no camera today. So, the purpose of these events was originally to give our hackathon participants a quick overview of how to use Git and GitHub to run their events and collaborate, or run their project and collaborate on their teams. However, I felt like it was such valuable information, I chose to open it up to everyone. So today we're going to do a very quick high-level overview of how Git and GitHub work, what some of the common terms mean, and get you ready to start making some contributions. Let me go ahead and share my screen. Okay. New button. Okay, before we get started, let's talk about what a repository is. A repository is effectively a box that holds all of the files for your project, whether it's code, images, documentation, settings, configuration. Your repository is essentially a special folder for all of that. So let's go ahead and start by creating a repository. So if we go to GitHub, we get this lovely little plus at the top. We're going to go ahead and click that, and then we'll select New Repository. And we get to this beautiful screen. Our first option here is to use what's called a template. Templates are special repositories that you might see in some organizations, or might have yourself, that allow you to pre-populate new repositories with some of your basic files. For example, I have a template that has my code of conduct, my README, my security policy, my license, all of that. So every time I create a new repository, I have all of those files already and don't have to re-add them. So if we click here, we can see a couple of templates. We have the templates we use at freeCodeCamp, the templates that are available to me at Deepgram. None of those will work for our demo today, so we are going to leave that blank. Our next choice is to define the owner. Now, the owner is essentially where you want your repository to live. You can, by default, pick your own user account, so this could just be my repository. Or you could select an organization where you have access to create repositories. As you can see, I have a few organizations here, and if we look at the freeCodeCamp organization, I cannot select that one because at freeCodeCamp we restrict our repository creation flow. For now, I'm going to put this repository in my own organization. And then we need a repository name. Your repository name generally should be a quick little title for your project. Now, the freeCodeCamp repository is freeCodeCamp. Our curriculum efforts are on a curriculum expansion repository. So we need a name for our repository. Let's call this freeCodeCamp GitHub Workshop 3, because this is our third workshop. If you're on a hackathon team, the suggested name probably looks similar to some of your team names. I took a similar approach when I created all of those channels. So our next option here is the description. And the description is kind of a quick little summary of what your product is and will display on the repository's homepage. So let's describe this as example repository for the third freeCodeCamp GitHub Workshop. Then we get to choose the visibility. So a private repository is kind of hidden in that only you can see it, or only the people with the necessary permissions in the organization can see it, or only people you invite to the repository can see it. A public repository, on the other hand, is visible to everyone. In fact, I do not even need to log into GitHub to see a public repository. However, that does not mean that anybody can come just do anything to your repository. People can fork it and make proposed changes, but ultimately you have to review those changes and accept them for them to be in your repository. And we'll go over what that flow looks like a little bit later. For now, I know I want everyone here to be able to see this repository, so we are going to mark it public. And then we get some options here to initialize our new repository with files. Our first file is a README file, and a README file can be considered to be the entry point for your documentation. The README file shows up on your repository's homepage. It is typically the first impression. It's the first place people will look to learn about your product. So it's kind of your space to describe what your product is, why it is important, how someone might use it, how someone might run it themselves, contributing, licensing, kind of a high-level overview of all of the information you want to convey. We definitely want a README in our repository, so we are going to go ahead and mark that. Your next option is a git ignore. A git ignore is a special file that tells Git not to track things based on patterns you provide. So, if we consider like a Node.js application, which has node modules, or maybe a Python application that has a venv, virtual environment folder, things that you do not necessarily want in your version history because there's either an easy way to set them up, like npm install, or because the approach is so personal to each contributor, everybody who runs your code, that it makes sense not to have any of it. Git ignore allows you to ignore those files. GitHub offers a whole list of templates that you can start with. So if I started with a Node.js template, it will probably include node modules. If I start with a Python template, it will include some Python files. We know that we do not want anything ignored in our repository, so we are going to leave this blank. Finally, we need to choose a license. A license is a very important document because it is a legally binding agreement that defines how people can use your code. There are quite a few options for licenses. Some of them have more restrictions than others. If you consider, for example, the BSD 3-clause license, which is what freeCodeCamp licenses our core application under, it's very permissive. You can do pretty much anything with software licensed under that license versus something like the new Avro public license, the GPL, which has stricter requirements, like if somebody modifies your code and wants to distribute their copy, they have to do so under the same GPL license and preserve all sorts of copyright notifications. Choosing a license can seem kind of intimidating. There are some cool sites like chooselicense.com that will help you make your decision, but ultimately, you want to take the time to ensure and understand that the license you are selecting best reflects what you want done with your software. Since we are not really building software today, we're going to start with no license. Great question. Yes, you can change the license later. However, there are some caveats here. If you start with a more permissive license and you then say, never mind, I want this to be licensed under something like GPL, your license is not necessarily retroactive. That means if you publish a version of your source code under the SD3 clause, and you make some updates to your source code and you're working on it, and then you decide, hey, I'm going to change the license to GPL, all of the code at that point in time going forward is under that license. But an earlier version of your work could still be licensed under the BSD3 clause. So generally, it's an okay idea. I personally, I wrote my own, excuse me. But, it's generally a good idea to take the time to make the correct decision prior to, you kind of want to get it right from the start, which is why I encourage you to take the time, read the actual licenses, understand, ask questions, and then decide how you want your product to be licensed. Okay. Our final section here, you may or may not have. The final section is where you grant apps access to your repository. You may have some cool GitHub applications you have installed, like DeepSource or CodeQL, which scan your code for quality issues, or Renovate, which manages dependencies and updates them automatically for you. Or maybe you installed something like SonarCloud. But so you may have some apps here, and you can choose whether or not to grant them access to the repository. In my case, I have given DeepSource access to all repositories in this organization, so I cannot actually tell it no. It's there, but that's okay. We aren't writing any code today. It can just sit there. Let's go ahead and create our repository. Now that we have a repository created, GitHub takes us to the repository homepage automatically. We can see here that it's in our NH org. We have our freeCodeCamp GitHub Workshop 3 title. We have our quick little description that we wrote, and then GitHub uses those to pre-populate the README, which is cool. This is a great start for our README. But the first thing I see and want to fix is that the title of our README is not properly title cased. So let's go ahead and fix that. We're going to hit the little pencil icon to edit the file right here on GitHub. And you should see that we now have kind of a basic looking text editor. Let's go ahead and change this. We want the same name, CodeCamp GitHub Workshop 3. We just want it to look like a proper title. So now that we have made that edit, let's go ahead and commit our changes. But what is a commit? A commit is essentially a snapshot of the state of your code at a given point in time. So you can think of it like hitting save, but for your entire repository. When Git then looks at those commits, it can identify the differences and track the differences so that it always knows the changes between any given number of commits. Really cool, really powerful, very, very in-depth stuff if you choose to go look at how it all works under the hood. But for now, let's just think of it as a snapshot of our code. We need to take a new snapshot because we've made some changes. So we're going to come over here and commit changes. Now we get this cool UI, and we have some components here we need to consider. Our first is the commit message. Now the commit message is essentially a clear and concise description of what this commit does. Different projects will have different standards for how they want commits written. For example, at freeCodeCamp, we use the conventional commit syntax. So let's use that here. So we're going to call this a docs update. So that's the type of commit we're making. We add a colon, and then we write our quick description. Let's call this use correct casing in title. Quick, short description. Then we get into our extended description. This is where we can wax lyrical about why these changes are important or additional information that someone might need to know if they look at the commit. In this case, let's add a little something. Let's just say the title was kebab cased by default, and we want it to be title cased. Cool. We have a description. This next little thing you may or may not see. Typically, you will only have one email address associated with your GitHub account, and that is the email address that you use to log in. However, sometimes you might want a different email address to be connected to your commits, because the email address you use on a commit is public, unless you configure GitHub with a no reply email address. In my case, I use my account's email to sign in, but I want to use my commit's email to actually make a commit. So let's change that. Finally, we have an option here to commit directly to our main branch or to create a new branch and start a pull request. We're going to cover that more a little bit later. So for now, let's just be a little naughty and commit directly to the main branch. We're going to go ahead and hit commit changes. GitHub will take us to our commit view where we can see the updated file, but we don't necessarily need to worry about this. Let's go back to our main repository. Now we can see the changes have been correctly applied to the README. Our title looks great. It's beautiful. It looks like a title. But we can also see our commit. So up at the top, because we have made the most recent commit, because we just made it now, you can see our short little message, the docs use correct casing in title. You can see that I wrote it. Be a little worried if I was giving a demo and wrote a commit, but I was somebody else. Talk about an identity crisis. We can see that we have 2 commits on the repository, and we can see the cool little hash for the repository. And then we got these 3 little dots. And if I click this, we can see where our extended description was saved in the commit. So writing a good, clear message and then using a description to explain more in detail really helps so that 2 years from now, when Jessica is working on this product and she's looking at the README and she's like, why the heck does this title look like a title? She can look at the commit history, see I made the changes, see why I made the changes, because I included that information in the commit. So it's very helpful to take the time to write clear commit messages to help preserve your thoughts. Because I don't know about you, but I wake up in the morning and don't remember why I committed code the night before. So great to great to give yourself a little extra help there. Okay, we want to add more information to this repository. We're going to tweak our README some more, but we want to do this locally. We don't want to keep editing files in the website. Maybe we have to make big amounts of changes. Maybe we got more stuff to do. Maybe we want to run cool things like spell check. So we need to be able to work on this right in our local machine. To do that, we have to do what's called a clone. A clone allows me to clone this remote repository from GitHub to a local repository on my computer. And you can do that by clicking the code button. And you will see a few options here. The first is the HTTPS URL. When you use HTTPS, you have to authenticate yourself using your GitHub username and a personal access token, or a PAT, which can be considered to be like an API key for your GitHub account. You cannot use your password. That feature was removed a few years ago. You have to use an access token. And even then, it is generally considered to be the less secure option, because your next option is SSH, which, to authenticate, does not use a personal access token, does not even need your GitHub username. Instead, it uses a public and private key pair. The public key you upload onto GitHub, and the private key stays right there on your local machine and never, ever, 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 ever is shared. It's completely private. If I have your private key, I am effectively you. You do not want me to steal your identity? Keep your private key private. And then finally, our third option is to use the GitHub CLI. The GitHub CLI is pretty darn neat. You can do some cool stuff. You can clone repositories, you can check out pull requests, you can create issues, all from your terminal. However, in this workshop, I am not going to cover the GitHub CLI. And I choose not to cover this because I want you to be able to take as much of the information you have learned today and apply it to your work, which might be on GitHub, which would be cool. You can use the CLI. But maybe you end up working somewhere that uses Gitty, or uses GitLab, or uses Codeberg. And all of these use Git, but aren't GitHub. The GitHub CLI will not work with them. So understanding how actual Git commands work and how to do your basic workflows with your Git commands is really going to prepare you for taking on a new job where all of the code is on GitLab and you can't use the GitHub CLI. So we are going to go ahead and use SSH because it's the most secure option. Before we clone this, I see a question about private keys and working from multiple machines. So your private key is on your machine and authenticates that machine as you. If, for example, like I do, you have multiple machines, say maybe a work laptop and a gaming desktop, you have a few options here. You can, as Logan suggested in chat, create a second SSH key and have two different keys for your two different machines and upload both to GitHub. GitHub completely supports that. It also works for connecting to remote servers. Perfectly fine. Totally cool. Absolutely valid. Kind of honestly how I recommend you do it. Another option would be to transfer your private key. Maybe you've got a USB stick floating around. You can copy your private key onto the USB stick, stick it in your second desktop, and put the key there. Obviously, there are some security risks there. If you forget to clean the USB properly and you lose it, I might have your key and your identity. If you use a cloud-based service, your key, your private key, is now out there. Maybe you use something like Google Drive. Cool. Sounds secure. Sounds great. Unless it gets compromised and your key is leaked. My approach is kind of in that same vein. I am taking a bit of a risk because I use 1Password to manage my SSH keys. And the reason I do that is less for the ability to use the same key on multiple machines, and much more for the ability to have 1Password manage the key entirely. So, in my setup, I do not have a private key on my machine. My private key sits in my 1Password vault. 1Password intercepts every SSH connection I make and prompts me for my password to authenticate that SSH connection with my private key that only 1Password has. Still some risk there, of course. If my password manager is compromised, somebody has my key, but honestly, if my password manager is compromised, I am in such a world of hurt that the key probably doesn't matter anymore. But yes, it's a very, very helpful thing. And in fact, you'll get to see it here in a minute because we're going to clone this repository using SSH. So let's copy this URL. And let's switch our workspace here and open a terminal and embiggen the terminal so everybody can actually see it. We need somewhere to put our repository on our machine. Where you choose to keep your repositories is entirely up to you. It's kind of a personal choice. I won't judge you if you keep it in your documents folder. I won't judge you if you put it on your desktop. I might judge you if you put it in your recycling bin because that would be really weird. Cool. If you can work on a repository out of your garbage bin, I'd be impressed. And I would love to see screenshots. Yes, I have just my one key in 1Password, and I use that key on my work machine, on my gaming machine. I can use it when I use it on my phone. It basically comes around everywhere with me because my password manager goes everywhere with me. So, going back to our clone here, I keep all of my projects in very specific folders. And for our workshops this weekend, I have been keeping everything in CodeCamp Workshop. Let's see what we have here. I'm going to do ls to show our content. Look at that. We have freeCodeCamp GitHub Workshop 1, freeCodeCamp GitHub Workshop 2. Let's get our freeCodeCamp GitHub Workshop 3 in here. We start with git clone, and we paste our URL. And we're just going to hit enter. Good enough. Now, Naomi has to go authenticate her password manager so her SSH key works. Don't steal my password. Ta-da! Cloned. Okay. No background in my terminal. Actually, all of my windows are slightly transparent. So you can maybe see the moon through the GitHub website too. So we have cloned our repository. And kind of like our repository is a folder for all of our code, what we end up with when we clone is a folder for all of our code. So let's look at our folder contents again. We see a new freeCodeCamp GitHub Workshop 3 folder. That's where our new repository is. We just cloned it. Let's check out what we got. We're going to change to that new directory. And let's take a look. It is fine to clone a repository in GitHub via your IDE. I do recommend that you take the time to get comfortable with the terminal commands and being in your terminal, because as you run into more complex workflow situations, it gets a lot harder to do stuff outside of the terminal, like through VS Code's integration or the GitHub desktop app. So yes, I recommend taking all the opportunity you can to explore the terminal. So if we look at our contents here, we see our README file, which we expect, but we also see this .git directory. This is a special folder that effectively holds all of the settings for your local Git repository. If you look in that folder, there's some weird stuff. There's lots of weird stuff, but this folder contains all of your branches, your commits, your commit history, where you want your code to push, where you want your code to pull from. All of that is kind of contained in this hidden folder. So, as a very, very strong rule of thumb, never touch this folder. You should not move it, you should not delete it, you should not open it, you should not edit stuff inside it. Anything you do to this folder might break something. Heck, I've been doing this for quite a few years now, and I don't touch that folder. It gets to be the little spider sitting in the corner above my bed. I know it's there. I know it's doing stuff. I hope it doesn't fall on my head. So, let's go ahead and work on our README a little more. And because we're only modifying one file, I like to use a terminal editor. In this case, I'm going to use Emacs. You can use Emacs, Vim, Nano, VS Code, Notepad, whatever kind of editor you want, whatever works for your workflow. But I'm going to use Emacs because that's what I usually do. And I open it in the terminal instead of in the window and edit the README. So if we look, we have our README. Beautiful. Looks great. Let's add some quick information about contributing. And let's write, this repository is your playground to freely explore features on GitHub and Git, like issues, commits, pull requests, and more. We're going to save our file. We're going to close our editor. So now we've made some changes, and the changes that we have made on our computer here are not on GitHub. You won't see them yet because we have not done anything to put them there. So, kind of like we wrote the commit on GitHub, we're going to write a commit here. But when you're working locally, there are some extra steps. First, let's take a quick look at where we are at right now. And we're going to do that with the git status command. So we see some information. We see we are on branch main. Our branch is up to date with origin main, which we'll explain a little bit what that means. Our changes are not staged for commit, and we have modified the README. So, here's where we start getting into the fun bits. In order to include files or changes in a commit, you need to stage them. And you stage them with the git add command. When you use git add, you're effectively telling Git, I would like to include this stuff in my next commit. And there are a few ways you can do that. You can git add and say readme.md. You could git add and say source index.js. You could say git add source to include the entire source directory. Or you can do what I'm about to do right now and git add dot, just to add everything. Every single thing in this folder should be committed. There are, again, a couple of warnings I need to share about using git add dot. First, if you decided that Naomi has no idea what she's talking about and I'm not going to listen to her and I'm going to move that .git directory somewhere else, you may end up in a situation where you open your documents folder, you make some changes in what you think is a repository, you hit git add dot, and you have now staged your entire documents folder for commits because you moved the .git folder. And then you push, and next thing you know, your tax forms are on GitHub. Thankfully, we know what we are adding because we have looked at the git status. We see that the changes not staged are a modification of the README. I feel pretty comfortable with that. I think that should be everything we want. Let's go ahead and git add. If everything goes well, you will not see any feedback from that command. It just goes. So let's see what happened. Let's look at our status again. If we look at our status, we can see we're on branch main. Our branch is still up to date. Changes now to be committed versus not staged for commit is our README. So now the changes we've made to our README are ready to be included in this commit. And now we will actually author the commit. And we do that with the git commit command. And there are a couple of ways you can do this. For example, you can pass the -m flag, and you can write your quick description, which would be that smaller box that we saw when we made a commit on GitHub. And we might say docs add contributing info. Cool, we can do that. That would work. But I like to just use git commit and not pass anything. And here's why. When we do git commit, Git will automatically open a new window in whatever we have configured for our default editor. In my case, I have configured Emacs because that's what I like to use. You can configure this to be Nano, Emacs, Vim, VS Code, Notepad, anything essentially that you can launch from a terminal command can be used by Git for the default editor. And the first thing we are going to see is a bunch of lines with these little hash symbols or pound symbols or octothorpes if you really want to get into the fun language trivia. Every line that starts with one of these symbols is a comment. And kind of like an HTML comment, it won't show up in the final result. In this case, this is all just for us. It goes away when we actually make this commit. And Git is trying to be helpful here. It's going to remind you that lines starting with a hash are ignored. It's going to tell you we're on branch main. It's going to say we're up to date with origin. It's going to say changes to be committed, modified, readme. This is kind of our chance to double check that our use of git add dot didn't do anything wrong. We've got just the stuff we want included in the commit. I do. I think this looks like a great commit. So we need to write our message again. And the message, again, is that little box that we saw in GitHub. It's our clear and concise description, and we're going to use a conventional commit style like we did earlier. This is another docs change. We are going to say add information about contributing. The first line of this file is your message. Anything after that falls under that extended description. So that big box that we saw when we made the commit on GitHub, where we could write all sorts of information. In this case, we're going to do some screaming because screaming is fun. We're going to say, whoa, look at this extended description. We are the best at writing commits because we are so cool. We're going to save this and we're going to close it. And once we close it, Git is basically waiting for us to close this. Once we close it, the commit is made. Ta-da! We have a commit. Now we need to get that commit back up on GitHub. And we do that by pushing it. Think of it like pushing a boulder up a hill. And we do that with the git push command. Now, one of the trickiest parts of running workshops like this is that I have done a lot of tweaking in my environment to make things as easy for myself as possible. Which means I have to show stuff to you that I don't actually need to do because I have tooling to do it for me. When we pushed from a branch, a local branch, Git may respond with a error message that it doesn't know where you want to push your commit. So sometimes you have to set that. So we use the -u flag to set what's called the upstream. We tell Git how we want this code to exist on GitHub. And we want it to push to our origin. You might not know what that means yet, and that's okay. We'll cover it shortly. And we want to push to our main branch. Ta-da! We have pushed. You see a bunch of stuff that's kind of some internal logging, effectively. Tells you how Git counts stuff, compresses it, writes it. Kind of cool if you're into, that kind of thing. Really fun when I'm pushing massive commits and watch it slowly count up. And then you see we've pushed to our origin main, and we've pushed from our main branch to our remote main branch. So now this is on GitHub. And before we go take a look at GitHub, let's talk briefly about what we just did. So to understand this, let's first talk about the different types of repositories. We have a local repository, which is the repository that's sitting right here on our computer. It's what we just edited in our terminal. It's what we cloned. It's the stuff that's on my computer that Jessica won't have because she doesn't have my computer. Please don't steal my computer. And then we have the remote repository. And the remote repository is the one that is up on the cloud. It's, in our case, up on GitHub. And you can configure where your remote repository lives, in a sense, with the git remote command. Let's take a look at what we have. So we're going to do git remote, and it tells us origin. Not very helpful, not very detailed. Honestly, what the heck does that even mean? But if we do git remote -v, then we get some more information. So let's talk about this. There are two components here. The first is this pesky origin again. What is that? That is your local name for the remote repository. By default, when you clone a repository, the remote you clone from is automatically set up as your origin. That's where it came from, where it started. Sometimes, though, you may need to pull changes in from an original repository. Say you fork freeCodeCamp, so you make a copy of that repository on your own account. You clone your copy. That's the origin. But you need to keep your copy up to date with freeCodeCamp's original, so you would add freeCodeCamp's original as the upstream, for example. So let's do that. Let's give ourselves an upstream. We're going to do git remote add upstream, which is the name we want to use for the remote. And let's do just the same URL, git@github.com, and HK again, freeCodeCamp, GitHub Workshop 3.git. Cool. Let's see if that worked. Git remote -v. And now we have an origin and an upstream. They're the same here because I wanted to show you how this works, but we don't really have an upstream because we didn't fork anything. We made our own repository. So it's weird to have an origin and an upstream locally that point to the same repository, but it won't break anything, so we can do that safely, so I can show you how that works. Okay, so we have pushed, if we go back up here, we have pushed the commit we wrote to our origin remote, which we know is our repository on GitHub because we just looked at our remotes, and we pushed to the main branch on that remote. Let's go take a look at GitHub. We're going to give our page a refresh, and we see our new contributing section of our README. We can also see our commit. Once again, Naomi authored the commit. That's me. I hope I don't have an identity crisis today. We can see the short message we wrote, which was the first line of that commit editor. We can see our extended description. Look at that. We are so cool. We wrote the best commits. And that was what we wrote after the first line in our editor. We can see we made the commit 9 minutes ago because somebody kept talking about other stuff like remotes. And we know our changes are here because we are staring right at them. That's cool. That's great. We have now pushed a commit from our local machine up to GitHub. But we're still kind of being naughty here. We keep pushing directly to our main branch, which is our default branch. As a general rule, you don't want to do that. You want to push to dedicated branches for your changes. And there's a few reasons for that. First, let's say Jessica and I are both working on this project. And I'm working on my changes, and I'm pushing to my main, or I'm committing to my main locally. And Jessica is following the proper workflow, and she's making branches and pull requests. And her pull requests get accepted, and now the main branch for the remote repository has her work, but my main branch locally only has my work. If I go to try to push, Git will reject my push because of divergent histories. That gets into some complicated stuff like merge conflicts and whatnot, which we don't really have the time to go over today. But we can avoid that entire mess by following Jessica's example and using proper branching flows. It can also create an issue if, say, we forked this from freeCodeCamp and we're working on our own copy, but we need to update our main branch with the changes in the freeCodeCamp upstream repository. If we do that, we lose the work that we have committed to our main branch that is not accepted in freeCodeCamp yet because we never made a pull request. Again, a lot of stuff can go wrong there. General rule, follow Jessica's example and use proper branching strategies. But what does that actually mean? Well, let's go ahead and talk about it. You can think of branches like roads. Let's say the main branch is your highway. It goes straight, and it goes straight forever, and it's huge, and it holds all of the cars. But I need to go work on some new feature. I need to add some JavaScript to this project. And I need to do so without blocking all of the traffic on my freeway. I can do that by getting off the freeway. So making a new branch is effectively taking the freeway exit, and then we'll get back on the freeway later in the process. So let's go ahead and make a branch. And you can use the git branch command to do this. But I am lazy, and I like to take shortcuts. So we are going to, let's clear our screen here. We are going to do git branch or git checkout. The checkout command allows you to kind of change the section of the map you're looking at. I can use checkout to switch from main to another branch, and Git will update all of my files locally to reflect that branch. I can use checkout to look at something like a specific commit or a tag or somebody else's branch. A lot of cool stuff you can do here. A lot of complicated stuff you can do here. We're just going to cover checking out branches. But we don't have any branches yet. Is acting up. Drop something in the chat if you can still hear me. I think, okay, it looks like I'm back. Cool. Awesome. Thank you. It was my gaming computer that was not catching up. So we need to make our branch. And we make our branch with the -b flag. And let's give our branch a good name. Let's call it feet/JavaScript. And we hit enter, and Git tells us that we've switched to a new branch. So at this state or at this point in time, we have just taken the freeway exit. We got off at the feet JavaScript exit. Now we can do some stuff without messing up our highway. Since we're going to get into some more complicated stuff here, some bigger changes, let's go ahead and open this in our IDE. In my case, I use VS Code, and I can open that just by writing code. We get our editor. We're going to close this terminal so it's out of our way. We have our editor, and we can see our beautiful README file. Let's go ahead and add a new file. Let's go ahead and call it index.js. And we're going to make this a very simple hello world file. So we're going to console log hello world, but we like to screen today, so we're screening. Now, if you have, say, configured Node locally already, you can run this. You make sure it works. Let's take a quick look because I do have Node. We're going to node index.js, see our hello world. Our JavaScript works. It's beautiful. It's the best JavaScript ever written. Nobody has written cooler JavaScript than this. So let's go ahead and commit these changes. Let's embiggen our terminal and hide that and take a look at our Git status. You see our index.js. It's not staged. If we open our file tree here, we'll see it's green because of my color theme. But more importantly, it's got this U symbol. The U indicates that this is an untracked file. An untracked file is something that is brand new. Git has never seen this before. We have just blown its mind with our invention of the best JavaScript in the world. So, like we had to do with the changes to our README, we want to stage this to be included in the commit. We're going to do the same, git add dot. And now you're going to see that that U changed to an A, because now it's been added to the staging area. It is ready to be committed. It is no longer untracked because we told JavaScript to start tracking it in this commit we're about to write. Let's write a commit. This time we will use the -m flag and just say feat add the best JS ever. Enter. And terminal's going a little wonky, but we should have our commit. Let's do a git status to make sure. We do not have our commit. Let's see what's going on here. We get to do some live debugging. We're going to try to commit again. Feat add best JS ever. There we go. New commit. Beautiful. We can see that this file is no longer green. It no longer has a U or an A because now nothing has been changed because our commit created our commit updated the state of the branch. Our changes are no longer changes. We've committed them. Now we need to push our commit. This time, because we are not pushing to main, our command is going to look just a teeny bit different. We're going to do the same git push. We're going to use -u to set the upstream for our branch. We still want to push to our origin, but this time we're going to push to the same feat/JavaScript. Yay, we have successfully pushed. I do not need to check out Soundboard. Thank you, Discord. Okay, let's go take a look at GitHub again. This time, we see this bright and shiny new banner that says, our feat JavaScript branch had recent pushes 2 seconds ago. Because we pushed to a new branch, GitHub thinks, hey, maybe you want to check out those changes and put them on your main branch, because that's a common flow. So it gives us a button to do that through what's called a pull request. Let's take a look. On our pull request, we have our base and our compare, or the head. We want our head to be the branch that has the changes we're proposing, in this case, our feat JavaScript branch. And we want the base to be where we want those changes to go. In this case, we want our changes to be accepted into the main branch. So we're comparing feat/JavaScript with main. We get a helpful, hey, this is your first pull request button or box tells us to read the documentation. We don't have any documentation. Let's get that out of the way. Then we have a title. Your title is effectively like the commit message. It should be a short, clear, and concise description of the changes included in your pull request. Because we only have one commit on this branch, GitHub has helpfully taken our commit message and added it as our issue title. I think that looks like a decent title, but I think we can do better. I think we can sneak some more screaming into our event and say, OMG, look at this best Java script in the universe. Clear and concise description of our changes. Then we have the big box, which is kind of like the extended description in a commit. This is our room to really explain why our pull request is important, talk about the approaches we took, talk about why we think it should be accepted. Lots of stuff that you can add here, and sometimes you might even see stuff already. We'll get into that a little bit later, but for now, we just have our empty description. And let's just say we're going to scream a bunch, because we can. That is the perfect amount of screaming. Okay. We've got a great description. Now, before I actually move forward, let me clarify. If you go onto anybody's project and you make a pull request that looks like this, you will be nuked from orbit. If you make a pull request like this on freeCodeCamp, I will have to block you from our organization. I do not want to do that. I do not want to kick you out. I love you guys. You're all great. And I would cry. Do not open a pull request that looks like this on freeCodeCamp or on anybody else's repository. Okay. Over here, we have a reviewer section. Sometimes, depending on repository settings, this may auto-populate with some folks. For example, at freeCodeCamp, it will automatically request a review from our dev team, so that somebody who is part of our core staff has eyes on the pull request. Because I have access to this repository, I can also set assignees, labels, projects, milestones. But if you're making a pull request to somebody else's work like freeCodeCamp, you won't be able to change these until you are given maintainer access, or if you're given maintainer access and the necessary permission to change these. So for now, we're going to ignore those. Let's take a look at the bottom here. GitHub tells us we have one commit, we've changed one file, and there's one contributor. This all makes sense. I only wrote one commit for this branch, I only modified the index.js file, and I am the only person who committed to this branch. Maybe Jessica is a maintainer for this repository, and she sees my branch and she says, hey, this is the greatest JavaScript in the world, but I know how to make it the greatest JavaScript in the universe. I'm going to push some changes to your branch. I say, cool, that's great. We love making code even better. She pushes her changes, and then we will see two contributors, because she has also authored a commit on this branch. She hasn't done that yet. That's okay. We have one contributor. We're good. We see our commit tree here, or our commit history. We see we wrote feat add best JS ever. Naomi committed it 6 minutes ago. All looks good. And we get a chance to double check our changes. We have added a new line. This is called a git diff, or essentially the difference between files. Since this is a new file, we have an addition of one line, a console log hello world, and GitHub gives us this little warning that we didn't add a line break at the end of the file, which is something that some computers, mainly Linux, I believe, can get kind of funky about if you don't have one, but that's okay. This is just for experimentation. So let's make this pull request. We're going to hit create pull request. Look at that. It's beautiful. Just the right amount of screaming. In the pull request view, we have an option to look at our commits, our single commit. We can look at our changes. We get the diff view again. We only have the one change. That all looks good. Then we get this yummy little button that says merge pull request. If you make a pull request to freeCodeCamp, you will probably not have this yummy little button because you won't have permission to merge a pull request. This is my repository, so I have full admin access, so I get the yummy little button, and we're going to click it. When we click it, we get that same UI that we had when we wrote a commit at the very beginning of this workshop. We have our commit message, we have our extended description, we have our email. We're just going to call that good, and let's merge it. Yay! Because we've merged this, and we know that we're done with our feat JavaScript branch, we're going to delete it. Yeet. Then let's go back to our main view here. You will probably not see the select email field because most of you very likely only have one email address on your GitHub account, and it's the one that you sign in with. So that's going to be the one that you use for your commits. If you do weird stuff like Naomi does, then you might get into situations where you have multiple emails. That's okay. Use the workflow that works for you. Don't worry if you don't get a box to choose an email. Okay, we look at our repository here. We see our beautiful index.js file. Yay, we did it. We have made a pull request. We have accepted the pull request. We have pulled those changes into our main branch. Now we want to start working on another feature. But we have some more stuff to do first. Let's take a quick look at GitHub issues. And we can do that with this issues button at the top. GitHub issues are effectively your built-in ticketing system to track work. You might use issues to track feature requests, bug reports, questions about documentation, and, many other things. Essentially, it's sort of like Jira or Trello or all of that, but right here on GitHub. Anybody who has a GitHub account and is signed in, by default, can open issues on your repository. You can turn them off, you can block people, but generally it's good to let folks come propose features or report bugs on your open source repository. Let's propose a feature right now, and we're going to do that with a new issue button, a blank issue, and we are going to say add issue and pull request templates and create. We did not write anything in the issue, so it says no description provided. That's fine because we're going to fix it so that people have to write in the issue. And we're going to do that in a couple ways. Let's go ahead and work on this issue. To do that, we need to go back to our editor here. We need to switch back to our main branch. So let's try git checkout -b main. That didn't work because the -b flag tells Git to create the branch. It can't create a main branch because we already have a main branch. So to switch back to that branch, we can use git checkout main without the -b flag. Let's take a look at what our branching situation is here. So we're going to do a git branch, and it's going to give us this nice little new window here. And we have our feet JavaScript branch down here at the bottom, and we have our main branch. And then we have the end because we only have the two branches. The main branch is highlighted and includes a star because that's what we have currently checked out. Let's switch back to our feet JavaScript branch. Now let's run git branch again. Git branch. I'll take some branch. This time, feet JavaScript is highlighted and has the star because that's the branch we have checked out. We hit Q to exit this screen. Let's go ahead and git checkout main again. And we're done with this feet JavaScript branch. It's been merged. We know it's been merged. We don't need it anymore. Let's go ahead and delete it. You could do that with git branch -d feet JavaScript. Our branch is now deleted. It's gone, lost to the abyss. But Git gives us this little warning here. It says it's deleting the branch feet JavaScript that has been merged to remote, our remote origin feet JavaScript, but not yet merged to head. This effectively means that Git is informing us that we pushed the branch up to our remote, but we haven't actually merged it into main. The problem is we did merge it into main. We made our pull request and we merged our pull request and we looked at our main branch and we saw it. It was there. So why doesn't Git know about it? Well, that's because Git is not a mind reader. It can try, and it will try, but it doesn't know everything. We need to tell it that there are changes on the remote repository we want to pull down to our local repository. If you remember when we were making commits earlier, we pushed those up to the remote. Now we're pulling down from the remote to local. So push up and pull down. And we do that with git pull. Git tells us the same kind of cool little information we see when we make a commit and push it. And it says we pulled from main, from origin main to main. It updated it and it did a fast forward, which is one of the strategies for pulling down changes. Honestly, I'm not entirely sure what it means. It just works. I do git pull and it works. If you would like to know more about that, I highly suggest checking out the Git documentation. And if you find out, come back into our community and tell me, because I love learning new stuff. And then we see in our file tree here, we have our index.js file back. Let's go ahead and shrink the terminal. We see our console log, hello world. This all looks beautiful. Okay, so our local repository is now up to date. We've pulled down the latest changes. Our main branch reflects what's on the remote. We can start working on our next thing. If you remember, we have an issue here to add issue and pull request templates. That's what we want to work on. So let's go back to our editor here. Let's go ahead and git checkout -b. We're making a new branch. We're going to call it feet/template. We're on a new branch. Let's do git branch to take a look. Feet templates is highlighted. It's there. We have main. Our JavaScript branch is gone because we deleted it. All right. I think we're good. We'll hit Q to close that and get back to our terminal. We'll go ahead and clear our terminal. We're going to go ahead and shrink it so we can see what we're doing here. And now we're ready to work. So, if you remember kind of way back at the beginning now, and I have been rambling a lot, so that feels like forever ago, we had that .git directory, which was kind of your secret little settings folder for everything related to Git. Similarly, we want a .github directory, which is going to hold all of our settings for GitHub. So let's go ahead and make that. It goes right at the root of our repository, and we call it .github. Yay! This is where we can add some really cool stuff, like issue templates and pull request templates. These templates effectively allow you to sort of guide and structure how you want users to open issues or open pull requests. Let's talk about all of that. We're going to look at what all of this looks like. And we're going to do some cheating, because I've done this already before, and we're going to go copy a bunch of stuff from an earlier workshop so that I can just start getting into it with you. So, let's go back to workshop number 1, workshop number 2, beautiful. We have our GitHub directory, and then we see some extra stuff. Right now, we care about this issue template directory. We need one of those. We're going to make one of those. And we have to scream. This is actually a requirement. I don't think this works if you don't scream. I think GitHub doesn't recognize it. Could be wrong. If I am wrong, tell us in the chat. Tell us in the community. I love being wrong. It's how I learn. And so we scream issue _template. And then we actually need our templates. So let's go look at what we have. We have a couple of things here. We have a bug report template and a feature request template. We're going to start with a feature request. It's going to look all pretty because of GitHub, but we're just going to get out of the way here. So we want to create our feature request.md. It's a markdown file. And let's just paste our stuff here. Now I'll walk you through it. So the first thing we are going to see is what's called front matter. Front matter is a special formatting for things like markdown documents that allow you to set document properties. You may have seen this before if you've poked around, say at freeCodeCamp's curriculum, where we use front matter to set things like a challenge title. Maybe you've seen it if you've poked around something like a Next.js blog, where you use front matter to control your posts. In this case, we are using front matter to tell GitHub what this template is. So we have a name. It's called a feature request template. We have an about, which is the description, and we say this template is for suggesting an idea for this project. We have a title, which when we hurriedly made our issue earlier, in fact, we can go back and look. Our title was Add Issue and Pull Request Templates. When we open an issue using this template, the title will start with this feature. It'll automatically fill in. It's going to do an enhancement label automatically for us, and it's not going to assign anybody. And all of that is great. That is exactly what we want. Then we have the actual markdown. So the front matter is bounded by these 3 dashes. That's how Markdown knows and GitHub knows front matter started, front matter ended. The markdown will automatically fill in that description box that we completely ignored when we made an issue. So we'll have stuff here instead of no description provided. We'll have a feature description header, and then we'll have this comment. And this comment will show up to the user as they're opening and writing their issue, but disappears in the final rendered view because it's a comment. Like an HTML comment. It's in the code, but you don't see it on the actual web page. We have some additional stuff here, some more information we want to collect. This is all great and beautiful. We're just going to save it. We're going to call that good. We're going to leave this as is. Because Markdown issue templates are cool for basic stuff, but did we lose audio? Don't do this to me, Discord. Are we back? Okay, we are back. Beautiful. Yeah, my recording software can hear it too, so. Don't do this to me. Did we break Discord? We might have broken Discord. Had a few people can hear. All right, so here's what we're going to do. If you cannot hear, take a moment to refresh, rejoin the stage, double check your audio settings. We're going to hang out for a bit and pause so you all can have a moment to do that and make sure that everything is working on your end without missing any information. Oh, good. Restarting seems to be working for folks. Deepak, yes, the recording will be uploaded on YouTube. Might take me a while so I can actually properly clean it up. Get rid of that moment where I leaked some internal chat channels. Oops, gotta hide that before I publish it. But the recording from session 2 last night has already been posted in announcements. I'm trying to cover kind of the same information in all of it. So you can use that recording if you need to revisit this immediately, and I'll get a cleaner, polished one up later. Okay, I think folks have had enough time to refresh. Let's go ahead and keep moving. I think I have about half an hour before I have to go get some groceries, so we're gonna pick it up a little bit here. Okay, issue templates are great. Gives the contributor some information to fill out when they're writing an issue, but they can totally just delete all of this and write whatever they want. They can come in and scream. We don't want that. We want some actual thoughtful issues. Thankfully, GitHub has a relatively new, maybe a couple of years now, feature called issue forms, and we can essentially create a form with some of your standard HTML inputs that the user has to fill out when they make their issue. Let's do that for a bug report template. Let me go back to this repository and go to issue template, and we have our bug report. And I'm just going to copy that real quick. We're going to go back to our issue template. We're going to do bug report. Now, when you want to create a form, you no longer use a markdown document. Instead, you need to use YAML, or yet another markup language. YAML is a standardized syntax, essentially, for setting a bunch of properties. The front matter that we saw in our markdown file, that's YAML. So we want the YML extension for YAML. You can also do YAML for YAML, but who wants to type extra letters? YML. And then let's paste it. And let's go all the way back up to the top. It kind of looks like our front matter with extra steps, because that's what it is. Our front matter is technically YAML. So with this, we have the name for our template, which is bug report. We have a description for our template, which is file a bug report. We have a title, which pre-populates with bug. We assign an awaiting triage label. And then we have our assignees. I am assigned to every bug report so that I can properly triage it. There's some weird syntax going on here, though, so let's talk about that real quick. Our title has to be in quotes because we're using symbols that YAML would otherwise parse as control characters, which we can see on the next line, where our two brackets here create a list, or an array if you're in JavaScript land. This would allow us to add multiple labels. So I could add a label called Naomi to every single bug report. Why not? Let's do it. TechBlue, that is a great question. It is not required to be the same. In fact, why don't we change it? Let's call this totally fake. Our code never has bugs. And we'll see what happens. Okay, now if we turn around and look at the assignees, this time it looks kind of like a markdown list. Effectively, we're doing the same thing we did here. But instead of an array, we're writing a literal list. So let's add my organization. Why not? We can see now that bug reports would be assigned to me and to the organization. That probably won't work. I don't think you can assign an entire organization. But hey, let's find out together. Then we get to the body. And this is where the meat of this feature is. It's quite a bit, so let's go ahead and hide our file tree so we can see everything. Our body is also a list, like our assignees is. But we're doing lists of effectively objects. So each dash denotes a new list item. Our first list item then is this whole thing. So let's look at that. We have a type markdown that tells GitHub that we want to use a markdown container. So this will be text that shows up when the user is filling out the form, but disappears when they submit it. Then we have attributes. In this case, we're setting a value. Now we see this little pipe symbol here, and that means that we want to include the text on the next line so that we don't have a long line that we can't read. The pipe symbol just says, hey, this is the same as this. Let's leave it like that. It's not as long as we thought. Then we have our next object, our next item. This is a text area. So this will render kind of like the HTML text area element. We have an ID. I stole this forever ago. I honestly don't even remember what the ID is for. I think you use it for some sort of automation. I think you can, trigger workflows that read the form or something. But you know what? We're just going to leave it because we know it works. And I don't fix what ain't broke. Then we have our attributes again. This time we have a label, which will be the title for the input, essentially. Then we have a description, which is kind of like a little subtext under the title that will tell your user how to fill out that particular box. We have a placeholder, which, like in HTML, shows up when the input is empty. And then we pre-populate a value so that the box starts with some content. The user can clear that out and they'll see the placeholder, but at least they get to start with something. After our attributes, we have validations, and we can use validations to control what the user can actually input in the box. In this case, all I'm doing is saying required true, which means this is going to be a required input. They have to fill something in there. I'm even nice, and I give them something to start. Our next object is going to be a dropdown. You can think of this like an HTML select element. Again, we have attributes, a label, which is the title. We have this multiple attribute set to true, which means the user can select multiple options. And then we have options for the 4 most popular, last time I ever looked at this anyway, browsers. And our dropdown asks what browsers are you seeing the problem on, so we give them browsers to choose from. I believe multiple is set to false by default, yes. But not 100% sure. I would double check the docs. And then we have another text area here. This one's a little different. We have our label and we have our description like we did in our first text area, but then we have this render attribute. This render attribute is set to shell, which means when a user fills out our form and enters something into this box, GitHub will automatically render it as a multi-line code block with syntax highlighting for shell language, which is cool. Most logs you see are going to be in some kind of shell language, so it makes sense to format your logs as shell. Finally, we have a checkboxes object. And our checkboxes object is kind of like checkboxes for HTML. You can define a bunch of checkbox items, add text to each one, and users can pick and choose which boxes to check. In this case, I have one. It's a code of conduct. I say by submitting this issue, you follow the code of conduct. I give them one checkbox under the options here with a label of I agree to follow this project's code of conduct, and I make it required. You have to follow my code of conduct in order to open a bug report. Or you have to lie and tick the box. You can do that too. I guess I don't really know. But if you don't follow it, I nuke you from orbit. So it's kind of a, good checkbox to try to get people to slow down and think about what they're contributing to. So that's it. We have an issue form. It looks like a mess because it is a mess. We're going to go ahead and save this, and then we're going to create some issues later so you can kind of see what this looks like. Before we do that, we also want a pull request template. So let's go back to our file tree. The pull request template does not live in the issue template folder. Even though pull requests are technically issues behind the scenes as far as GitHub is concerned, this just goes in the GitHub directory itself. So we're going to right click on GitHub, and like the issue template, we got to scream. So we're going to say pull _ request _ template .md because we have to use a markdown file here. I have been begging GitHub for a few years now. At every maintainer summit I've been invited to, I've been begging and begging and begging for pull request forms. We still don't have them. Last I checked, I haven't heard anything. So we still have to use markdown for our pull request templates, which is okay. Fun fact, my Gitty instance supports pull request templates, and oh my gosh, it is a dream. We're going to go ahead and steal this right from our last repository. We're just going to copy the file. We're going to come back here. That's twice now I've leaked chat. Paste it. Yay! Okay, unlike an issue template, a pull request template does not need front matter. It's just some markdown that shows up in the description box. Ours is actually blatantly stolen from freeCodeCamp. I just ripped this right out of there yesterday. It's got the checklist. It's got instructions that the user can see to put X in the checkboxes, like so. They have to confirm they read the contributing guide, pull request targets main, tested changes locally, closes X. Cool. We'll cover the closes bit a little later. But that's good. That's a beautiful template. So we're going to save it. And then let's embiggen our terminal again. And let's take a look at our Git status. This time, we only see the GitHub folder. And we can see it's untracked. But because the entire folder is untracked, it's new, Git does not yet actually care about what's in the folder. It just says, hey, this new folder has stuff in it. And none of it's tracked, so the folder isn't tracked. Maybe you should track your folder. So we're going to go ahead and git add like we normally do. We're going to git add everything because we do want everything that's in that folder. Let's look at our status again. Now that we've added them to the staging area, they're being tracked, and now Git says, oh, hey, there's 3 files in here, and we're staging all 3 files. We want that. We want our bug report YAML, our feature request markdown, our pull request template markdown. Looks great. Let's commit it. Git add templates. Beautiful. Committed. Added 3 files. We're going to push. Okay. Let's go take a look at GitHub again. And let's look at the right repository. If we go to the pull request tab or the code tab, we have the super helpful banner. It says we push defeat templates, make a pull request. Let's take a look. Our pull request template doesn't work. It's not here. What happened? Well, actually, because the pull request template is not on the default branch yet, GitHub won't use it. We're proposing it right now in this pull request, so we would not expect to see it yet. Let's go ahead and we're going to leave our description blank. No, we're not. I lied. We're going to use the closes keyword. We saw that in our template. It was closes and then hash and then a bunch of X's. But we can use that here. We're going to do closes and then we're going to do a hash, and it's going to show us our issues and pull requests. We're closing issue number 2 with this pull request because we have added the templates. Great. Beautiful. We take a quick peek. We have 1 commit. 3 files have changed. I'm the only contributor. There's my beautiful commit. We have our bug report form, our feature request template, and our pull request template. Let's create a pull request. Beautiful. Now, we are going to deviate from what I've taught in the earlier workshops real quick because Jessica has brought up a valid point. Let's look at how review suggestions work. I am reviewing this PR, and I think this description is terrible. I can click the plus icon here to add a comment, and I can click the plus minus here to create a suggestion. And I can say, it is impossible that you have anything to report. And we're going to start a review. You will see now a diff like we've seen in the pull request. This time, with the change as it currently is, file a bug report, my proposed update to that line, and you can see that the actual changes between what's there and what I think should be there are highlighted. How Git determines who the difference is can be a little bit wonky. Sometimes you'll see really weird diffs, but generally they should look kind of like that. Then let's say we want to remove my NH Carrigan assignee. We can suggest across multiple lines. And we can say, yoink that one. Add a review comment. We'll get to see it. It's pending because we haven't submitted our review yet. But we can see Git got a little weird with the diff. It says, take all 3 lines out, put 2 lines back in. Like I said, gets wonky, kind of fun to look at, kind of weird sometimes, but kind of gets the general idea across. We're taking out that line. let's go ahead and finish our review. Typically, when you are reviewing a pull request and you are proposing changes, you would tick Request Changes. Request Changes sets your pull request to a review that says change stuff. And GitHub uses that flag essentially to say, okay, chances are we shouldn't merge this yet. Maybe your branch protection rules say you can't merge it yet. If you don't have any changes and you think the pull request looks great and you're ready to accept it, you would choose Approve. I cannot do either of those because this is my own pull request, and it would be silly to approve my own changes. I would do it, but it won't let me. So we can only leave a comment review, which is just a general conversational review. We're not actually saying we want changes. We're not approving. We're just saying, hey, here's some thoughts. So let's go ahead and submit our review. Okay, somebody has reviewed my pull request and they've suggested changes. Oh no, what do I do? What can I do? Well, I could go through my files locally and copy paste some changes, but that's a lot of work, especially when you get into bigger PRs. Instead, I can create a commit with the changes directly on GitHub. So, we see this commit suggestion button, which is great. We can commit the suggestion. Gives us this nice little commit UI. We could commit it. But we see that there's more than one suggestion. If we commit every single suggestion individually, that can get very noisy. Even more so on a repository like freeCodeCamp, where each commit triggers a whole bunch of workflows that take a lot of time to run. We want to be respectful of the maintainer's time and of GitHub's resources, and we want to do this all at once. To do that, we have to come back up here, switch to the Files view, and then we see the Add Suggestion to Batch button is clickable. We like this suggestion, let's add it to the batch. We like this suggestion, let's add it to the batch. Everything looks good. We have no other suggestions. Now, we can commit suggestions. Why is it all the way over there, GitHub? What are you doing? Refresh. All right, let's try that again, shall we? Well, okay, there we go. And like we did before, let's write a commit message. This time, we're going to call this a chore. Not because it's a chore to accept review requested suggestions, but because chore is the type you use in conventional commits for something like making a bunch of sweeping tweaks. We've accepted 2 different suggestions, so it's a chore. It's just some kind of like cleanup maintenance work in the commit. We're going to say apply review suggestions. If we commit the changes, we go back to our pull request here, and we can see that we have a commit. It looks like we actually didn't get that one in there. So let's commit that one too, just like that. And because we've accepted these changes, GitHub has marked these conversations as resolved. Because there's no further conversation to have. We accepted the change. It's done. It's over. Let's go ahead and merge our pull request. Ta-da! And we can delete the branch. And we switch back to our code. And we can see our GitHub directory exists on our main branch now. Let's go ahead and make a couple issues. Oh, sorry. If you remember, in our pull request, we said closes number 2. That tells GitHub that once this is merged, it should automatically close issue number 2 because this pull request fixes that issue. In our case, issue number 2 was to add issue and pull request templates. We definitely did that. So we indicated that the PR closes at this issue, and it automatically closed as part of the pull request. Super helpful for tying changes and branches and your work to your actual tickets. Use it all the time at freeCodeCamp. Great feature. Honestly, one of the best, and precisely why I prefer to use GitHub issues versus an external platform like Trello. So let's go back to our issues here, and let's try making one. Now we see a couple new options. We have a feature request, which is that markdown template we used. Let's make a feature request. We can see we have pre-populated our feature title, and we're going to say code should do stuff. Then we get the template, and it's just the markdown box, which we can edit. I could delete this title. In fact, let's delete motivation. We don't want that. I'm not motivated today. Do stuff. Our proposed solution, do more stuff. Alternatives considered, do less stuff. Additional context. No things, though. Only stuff. Let's create our issue. Look at that. We have a beautiful markdown issue. We can see our headings because I didn't delete them when I wrote the issue. We don't see motivation because I deleted that one. And we don't see the comments because they aren't rendered, but they are still there. If we edit this, look at that. Our comments are still there. They just don't show up because they're comments. Cool. What about the issue form? Let's go make a totally fake bug report because our code never has bugs. It's impossible we have something to report. Let's take a look. This is the magic. This is why we spent so much time digging into that YAML file and writing all that mess. Because now we have a form. We have our title, which, if we remember, bug report. We filled it in here, bug, title. If we go down to the bottom, we see assignee and label, which came from our label and our assignee. Then we see, let's make a title. I saw a spider. Then we see here, thanks for taking the time to fill out this bug report. That's the markdown that we set to show up in the form. User can't edit it, can't get rid of it. It's there. Then we have what's happened. We can see here our title, what happened. Our description was also tell us what did you expect to happen. Also tell us what did you expect to happen. We've pre-populated our value of a bug happened. Let's delete that value. When the input is empty, we see our placeholder. Tell us what you see. Tell us what you see. Perfect. So let's write. Actually, let's leave it blank. What browsers are we seeing the problem on? You know what? I saw a spider on Firefox. I saw a spider on Chrome. I saw a spider on Microsoft Edge. I didn't see any spiders on Safari because spiders are too new of a feature and Safari doesn't support it yet. Then we have our log output box. And here we're going to say Spooter. Just because we can. It's a spider. We saw spiders. If we take a peek at our issue form again, we had our dropdown with browsers. What browsers are you seeing the problem on? Multiple worked. I could select all of them, but I didn't select Safari. We see our text area, relevant log output. we saw our description, right? We saw our description. You don't see the render here, but you will. Just wait. There's some magic. So we filled in some text. We see finally our checkbox. We have our label and our description, code of conduct, description. This is Markdown, so you can do cool links like this. We see our one checkbox. I agree to follow the code of conduct. It is required. We see the little star that indicates it's required. Let's check the box, and let's create our issue. We click the Create button, and GitHub tells us you can't submit this because we didn't write anything here. So let's write something here. Issue form says, what happened? There was a spider. And then it says, what did you expect to happen? We expected no spiders. Cool. Let's try to create it again. This time, because we have the required fields filled out, we successfully create our issue. We can see that markdown all the way at the top here, the thanks for taking the time to fill out this bug report markdown is gone. It only shows up while the user is filling the form. Markdown fields like that are a great way to provide instruction to the user. But we do see what happened. There was a spider. We see browsers. We see the list we chose. We see log output. And this is a multi-line code block because we said render a shell. So if we edit this to take a peek, you can see it's a multi-line code block in the shell language with our content. We see our code of conduct. We see the tick box. We're done. Jessica has proposed a fix. Burn the spider with fire. So let's make a quick fix. Let's burn a spider with fire. We're going to do this directly on GitHub because we are really out of time today. And I want to make sure I have time for your questions. So we're just going to go to our index.js here. We're going to edit. We're going to say document query selector all spider. And then to do delete spiders. We're going to commit this real quick. I'm going to say whip because it's a work in progress. Remove spiders. We don't want to commit this directly to our main branch because we're not done yet. We've only found the spiders. We haven't actually deleted them. So we're going to create a new branch. GitHub's going to give us this really ugly name. It's my username, patch number 1. That's terrible. We're going to say fix no spooters. And then we can go ahead and propose our changes. It'll take us to our pull request view. This time, because our pull request template is on our main branch, we see the template. Kind of like our issue template, I could delete all of this, but I'm going to be respectful. I'm going to tick the 2 boxes. I followed the contribution guidelines. I target the main branch because our base is main, but I did not test this locally, and I don't like to lie, so I'm going to leave that one blank. Here's the thing. We're not done yet, so we can't say that this pull request closes issue, because it doesn't. If it gets merged right now, the issue isn't actually solved. But we can say related to an issue, and we're going to say related to 5. Let's make our pull request. Look at that, beautiful. Our template renders as markdown properly. We could merge it, but we don't want to yet. And if we go to our issues here, we can see that I mentioned this now as whip remove spiders. Let's go back to our pull request. Let's merge it. Yay! Now, if we go back to our issue, it does not automatically close because we did not use the closes keyword. But we can see that we have mentioned it. So if Jessica comes back tomorrow and says, I'm going to remove the spiders, I can work on this, she can look at the issue and see a link to the pull request that I've already done that's related to the issue. This helps kind of keep all of the conversations centralized so that when you have multiple members on a team working on different things, you can all stay in the loop with each other. With that, I do have to call it here. Unfortunately, we did not get a chance to cover workflows and branch protections, but we did cover those in the session last night, and they are in the recording, so I highly encourage you to go check that out. This recording will also be published, probably not right away, because I have to edit the 50 million times that I accidentally clicked to the work chat. But I should get this up, hopefully, within a couple of days or so. Before we finish, I would like to open the floor to anybody who has questions. You can either ask your question in chat, or you can hit the request to speak button, come up on stage, and ask it in front of everybody. Automatically closing an issue is enabled by default, using that closes keyword. We'll have some dead space here while I give folks time to type. Is there a bash terminal you recommend for Windows outside of the one in VS Code? Okay. So that's a long answer here. You can get a bash terminal by downloading Git Bash. It's going to give you as much of a Unix-like environment as it can, and is going to support as many bash commands as it can. But unfortunately, you're still on Windows, and Windows is the operating system that says we gotta be different. They use a different separator in their paths. They use entirely different commands. They're off doing their own thing, being Microsoft. So, I will say that Microsoft has put a lot of work into what's called WSL, or Windows Subsystems for Linux. I also use Arch, by the way. Windows Subsystems for Linux allows you to essentially create a Linux VM in your Windows machine. But unlike a regular virtual machine, it's not completely sandboxed. So your WSL can interface and operate with your Windows environment. You can do some cool stuff, especially if you're on Windows 11 and have the graphical interface capabilities in WSL, to do things like open a browser in Linux on your Windows desktop. Really cool stuff. That's absolutely what I would recommend for anybody who's working on a Windows machine but needs a Nix-like environment. While people type, I also want to say I talked a lot about not making terrible issues and not making terrible pull requests and really not doing everything we did to show you how GitHub works today. That being said, this repository itself is your playground. You have all of the permission to make issues, to make pull requests, to poke at things, to do whatever. You can use this repository specifically to do all that practice so that you aren't doing it on somebody's actual project where you're going to get blocked. I will not block you from my organization for spamming this repository. This is your playground. It is my gift to you. Go nuts and have fun. Understand better how SSH keys work. I can give a very, very quick recap of that. Yes, there are guides, actually. Let me turn off the screen share here. So that I can actually go get you a guide. Yeah, don't do that on an actual repository. But you can do it on this one. Go nuts. Here we go. So GitHub actually has loads of documentation on setting up SSH keys. Very good stuff. It's how I figured it out. I don't even want to look at my notifications. How many do I have? $476 notifications. I should probably do something about that at some point. Oops. Yes, I do have to get going for groceries here very soon. In fact, I think that will be the conclusion to our workshop today. I want to take a moment to thank all of you for coming out and participating, asking your questions. I hope that this has been engaging and informative for you. If you have questions we have not covered, please feel free to ping me in the Discord. I am more than happy to assist and help guide you with any questions you might have. As you may have seen in this workshop, if I don't know the answer, I'll just flat out tell you I don't know the answer, and then we'll learn it together. With that, it's been real, it's been fun, it's even been real fun. We will see you all next time.